Recall the pizza diagrams where we saw 1/3 equals 2/6, 3/4 equals 6/8, and 2/5 equals 6/15. Remember that these examples led to understanding the following question and answer. Why is A over B equal to A times C over B times C true? In other words, why is it okay to take a fraction and multiply the top and bottom by C, or start with a fraction that has a times C on top and bottom and then cancel those out? So without going through all of the details of exactly how again, the summary is this statement. So we saw several examples, but it led to a short, concise answer that looks like this. Eating A slices out of B total slices is the same amount of food as eating AC slices out of a total of BC slices. So as an example, taking 3/7 multiplying by 10 on top and bottom leads to 30/70ths. And if you do this in reverse, you can look at 30 over 70 and say, hey, there's a times 10 on top and a times 10 on bottom, and you can cancel both of those and get 3/7. Now, you can multiply the same thing on top and bottom, and therefore you can also undo multiplying by the same thing on top and bottom. Now, you can't add the same thing on top and bottom or undo adding the same thing on top and bottom. That is, if you took 2/7 and you undo a plus 2 on top and bottom, you'd be left with 0/5, which would equal 0. And that is not going to be the same value as 2/7. Okay, so we'll look at this formula. A over B equals A times C over B times C, the one that we've already looked at before and have typically only used for fractions with numbers. But just like we took 3/7 and multiplied by 10 on top and bottom to get 30/70ths, we could take 3/7 and multiply by x on top and bottom to get 3x over 7x, or multiply by x squared y on top and bottom to get 3x squared y over 7x squared y. Or we can take 3/7 and multiply by x plus 1 on top and bottom and have 3 times quantity x plus 1 over 7 times quantity x plus 1. And we can do these sorts of things in reverse. So just like we started with 3 times 10 over 7 times 10 and canceled the times 10 on top and bottom to get 3/7, we could start with 3x over 7x and cancel the factor of x on top and bottom. We could take 3 times quantity z minus 5 over 7 times quantity z minus 5 and cancel the factor of z minus 5 on top and bottom. So turning A times C over B times C into A over B is canceling C, and you can only cancel factors, that is, things being multiplied on top and bottom. And this is true whether those things are numbers or variables or larger expressions such as x plus 1. So suppose you have a fraction whose numerator is 2x plus 1 times 3y squared minus 8 times z to the fourth. Then 2x plus 1 is a factor of the numerator, but 2x is not. So this 2x plus 1 is being multiplied by the other things, but you don't have here 2x times other stuff. Same deal, 3y squared minus 8 is a factor, but y squared is not. Is z cubed a factor of 2x plus 1 times 3y squared minus 8 times z to the fourth? It sure doesn't look like it is, but it can be, so you just have to rewrite the z to the fourth as z times z cubed. Then we see that we've got z cubed times this other stuff, so in fact z cubed is a factor. It's important to know what's a factor of the numerator, and for that matter, what's a factor of the denominator, since these are the only things that you can cancel in a fraction. So let's take a look at this fraction. Let's simplify 2x plus 1 times 3y squared minus 8 times z to the fourth, all divided by z to the third times 2x plus 1 times 3y squared. Notice that 3y squared minus 8 is a factor of the numerator, right? The numerator is 3y squared minus 8 times other stuff, but 3y squared minus 8 is not a factor of the denominator, so no cancellation there. 3y squared is a factor of the denominator. See, the denominator has 3y squared times other stuff, but this is not a factor of the numerator, so no cancellation there. Z cubed is a factor of the numerator and the denominator. In the denominator, it's a little more obvious because there's a z cubed staring at us right there. And the numerator, sure, it has a factor of z cubed because of what we had just talked about previous slide, so there is cancellation there. Also, 2x plus 1 is a factor of both the numerator and denominator. There's cancellation there. So if we just slightly shuffle and organize this stuff a little differently, we could point out that there's a z cubed factor and a 2x plus 1 factor both on top and on bottom, and the rest of the stuff in the numerator would be a 3y squared minus 8 in parentheses times a z. In the denominator, after that common factor stuff, what would be left is 3y squared. So the z cubeds on top and bottom cancel, the 2x plus 1 on top and bottom cancel, and you're going to be left with z times the quantity, 3y squared minus 8, all over 3y squared, and nothing else is going to cancel. So since z cubed times quantity 2x plus 1 appeared as a factor on top and on bottom, we could cancel. And in this final answer here, there's no other cancellations that are possible. So the 3 won't cancel with the 3, y squared won't cancel with y squared, 3y squared won't cancel with 3y squared, and all the problem really is that in the denominator you've got factors, but in the numerator, 3y squared is not a factor. The numerator does not say 3y squared times other stuff. It says z times this other thing, 3y squared minus 8. So 3y squared minus 8 would be a factor, z would be a factor, but not 3y squared. So there's no other cancellations. Let's simplify x squared minus 1 over 3x squared plus 3x. So as written, nothing is going to cancel because we don't have factors, because there's a minus in the numerator, there's a plus in the denominator. So yeah, x squared on top and x squared on bottom, these do not cancel because these are not factors. So we need factors in order to cancel. Well, let's factor, right? So this sounds strange, but factoring creates factors. We should factor the top and we should factor the bottom. This will create factors. Yeah, once we've factored, let's go then after we factored, let's see if any factors on top and bottom will cancel. So first, for the answer, just because there's all these other blocks in the way, I recopied the problem, or rather recopied the expression in the problem. Let's factor the top. That's a difference of squares, so x plus 1 times x minus 1. In the denominator, we have to undo the distributive law, so factor out a 3x, and you'll have 3x times the quantity x plus 1. So you'll see that there's an x plus 1 factor on top and bottom, which cancel. You're left with an x minus 1, which you can optionally have in parentheses or not. And in the denominator, what's left after canceling? Well, you'll just have that 3x. And now nothing else will cancel. The x on top and bottom won't cancel. There's no other cancellations. Here's why. The x in the denominator is a factor, right? The 3 times x, okay? But the problem is that the x in the numerator is not a factor. You have x minus 1. See, this x is a term, not a factor. Oh, if it were a factor, we could cancel more, but it's not, so there's no further cancellations.